Hello everyone, myself Monica History Wedding USA 1 May 20 from Sri Venkateshwara College of Engineering, Department of CSE. Today I'll be gonna discussing about elliptical curve arithmetic. In this video I'll be talking about the introduction. Topics which I'm covering in this video uh, is introduction, trapdoor function, how the trapdoor function works, and also about the ECC algorithm. Wherein ECC we're gonna be discussing about key exchange, how the key exchange works, and what are the process which is required um, to generate the key, and also encryption, and also we'll be discussing about the decryption and digital signature. So coming to the introduction, so what is it? What is it? Elliptical curve. Curve. It is asymmetric and it is also public key crypto system. So key is generated. So it provides a equal security with smaller key size. If you have the smaller key size, the security will be high. If you have the largest key size, the security will be low as compared to non ECC algorithm. So when we compare to RSA, it has a smaller key size, whereas high security will be provided. This makes use of elliptic curve. So elliptical curve is also defined as the mathematical functions cube. It is symmetric to the x-axis. So as we can see in this diagram, we are choosing the equation degree of 3. So by using this yeah, equation, we are generating. So y is equals to x cube, y is equals to x cube ax plus uh, p. So it is symmetric to x-axis. If we draw a line, it should touches minimum a maximum of 3 points. So in this diagram, as we can see, the curve. Um, so it starts from P, it touches Q, and also it touches R. So go moving on to the next slide. So trapdoor function, it's a function that is easy to compute in one. Q is equals to so direction. So a difficulty to compute in a opposite direction. Finding its inverse without special information called as a trapdoor. So in this diagram, if x is a trapdoor function, so if we have to find x is a trapdoor function. So from x, we have to go to y equals to f of x. If we move from x to y, it is easy. When we move from y to x, y is equals to f of x from f of x to x, it is very difficult. Um, y is equals to f of x to x easy, where it is taken t. Q is equals to kp, where q and p points are on curve, where q and p points are on curves, and the k value should be always less than n. Uh, K is the secret scalar, like for example, like ECDLP refers to the function that is easy to compute in one direction. And then moving, this is all about the trapdoor function. So let us see how the ECC algorithm works and what are the function which is used in ECC algorithm and arithmetical functions as well. So if we look into the ECC function, that the first comes is the key generation. So we are choosing an elliptical curve E, which is defined over finite field EP, where P is the large prime number. So P will let us consider it as a large prime number. Select a base point G on a curve E, and then private key we are choosing it as D on a random integer from the range of um, 1, 1 minus 1 to 1 n minus 1, where here n is the order of G, n is the order of G. So we are calculating the public key, where public key, the Q is the public key. So Q is equals to D into G, where the Q is equals to D into G represents the point multiplication on the elliptical curve. This is about the key generation. So we are using the formula Q is equals to D into G, and finding out the multiplication of it. That's what the product of it, and finding out the key generation. And next comes the encryption. So encryption of the message in the plain text message here. So M is the plain text message. The recipient public key is Q. So even here we are choosing the random integer k from the range 1 to 1 minus 1 to 1 to n minus 1. Ciphertext we are taking it as C is equals to K into G M XOR H and K into Q, where H represents the cryptographic hash function, and the symbol which we are using in the ciphertext, it represents the bitwise XOR gate. This is encryption. This is how we encrypt the message. And coming to the decryption, it is the opposite of encryption. So, given the ciphertext, it has C and recipient recipient private key has D. So, in here, we are computing the K into G from first uh, component of C using the private key D. Compute M is equals to C2 XOR H and K into Q, where C2 is the second uh, component of the function. So, as I already said, decryption is the opposite to the encryption, where we are inversing the encrypted language to the decrypted message. So, by using some of the formulas and using um, using the keys of lesser values, and to gain a high security and high privacy for your message. And then um, signatures. Digital signatures are very important, and there are two methods which is very important: signing and verifying. So in signing, we are giving the message, and signals private key is D. So message is CM, private key is D. We are computing the hash message. So H of M. So by choosing the random integer k in the range 1 to n minus 1, computing the signature R and S, whereas R into G, and also by using the formula where k minus 1 is the modular inverse of k mod n. The formula is S is equals to k minus 1 h of m plus dr, where h of m is the hash of the message. And verifying the message, we are using the same message is same, signature is RNS, and public key is Q. By computing W is equals to S minus 1 mod n, and U1 is equals to H of M into W mod n. So H of M is the as hash message. Compute U2 is equals to R into W mod n. And also computing r is equals to u1 into g plus u2 into q, which is to verify if r is equal to r from the signature from the coordinate of r. So this is all about the elliptical curve arithmetic cryptography. I hope you understood. uh, Thank you so much for watching.